In this video, we will be solving this question, this LeetCode 83 remove duplicates from sorted list. So given the head of a sorted linked list, delete all the duplicates such that each element appears only once, and after that return the linked list sorted as well. Okay, so but it really means is that you have to delete all the nodes which are duplicates of another node, and you have to return the node which does not have any duplicate. So we can see here that in this one linked list, this this 3 have a duplicate, which is this 3. Okay, so I'm going to remove this 5 have a duplicate, which is this 5, and I'm going to remove this. After removing these nodes, I will be getting 2, 3, 4, 5, and then no. So you will be given this kind of a linked list, and after that you just have to convert this to 8, and it does not have any duplicates. So let's do this. So let's see how we can do this. So to find the duplicates, we're going to use 2 pointers. One pointer will be pointing here and another just after it. What is going to happen is that like this pointer is having the value 2. This next pointer, we're going to check that do this have the same value or not. So basically I just have to check do the next node have the same value or not. If the next node have the same value of this pointer, like this pointer is holding this value, I'm just gonna check the next node also. So if the next node had the same value as this node, that means this node have a duplicate. Like the way I'm gonna check it, this one, that okay, this is a duplicate, because the list is in ascending order, so you cannot say this thing that 2 can appear somewhere here also, because that is not possible. The duplicates will always going to be the next of it. Okay, so what I can do, like the way I took 2 pointers here, so I'm going to compare the value right now. So I'm going to see that 2 and 3 are different. That means 2 does not have any duplicate. Okay, that then I'm going to move ahead. I'm going to move both of these pointers ahead. I'm going to put my pointer here. Now I'm going to check for 3. Do 3 have any duplicate? So I'm going to check the next node. Yes, 3 have a duplicate. So as soon as I finds out this thing that 3 have a duplicate, what I can do is that I can just connect this 3's next to this 4. Basically like the next of this. Okay. So if I do this like right now, if I write this thing that 3's next is equals to 3. Okay. We can see that 3's next is 3. So if I make the 3's next 4, so after doing this, this 3 will gonna get removed from here, and my this 3 will gonna point automatically to this 4 because of this line. Okay, and that 3 that was here got removed automatically. That lost the connection to this node. Okay, because I made this node's next as 4. So you can see that my duplicate has removed. Now what I'm gonna do, like right away, now I'm gonna check again. Okay, I'm gonna take that pointer that I was checking the duplicates for, and I'm gonna check again. Do 3 have more duplicates? So I'm gonna see that this 3 and this 4 are not equal. That means 3 does not have more duplicates anymore. So I'm simply gonna move both of the pointers ahead. Firstly, I'm gonna remove this, and I'm gonna move both of the pointers ahead, and then I'm gonna check do this 4 have duplicate or not. So I'm going to put it here, I'm going to put it here. Then I'm going to check do this 4 have duplicate. So I'm going to see that this 4 and 5 are not equal. That means 4 does not have any duplicate. Then I'm going to move ahead again. I'm going to check both of the pointers, going to put it here. Now I'm going to check do 5 have duplicate. Yes, 5 does have a duplicate because these two are equal. These two pointer values are equal. Okay, so as soon as I finds out this thing that this pointer got is duplicate just next of it, so I'm gonna just assign this pointers next to the next of where I found the duplicate. Like right now I found a duplicate here, right? So I'm simply gonna move this pointer ahead here, and I can simply attach this to this. Okay, so as I can see that 5's next is equals to 5. Then I'm just gonna make 5's next equals to null, which is this pointer is holding. Okay, when I'm gonna do this, this 5 will gonna get removed from here, and my 5 will gonna point straight to this null. So I can remove these permanently now because one of my pointers came to null. So I know this thing that I cannot find any more duplicates. My list have ended now. Okay. So now you can see this thing that this is our resultant linked list. This is what I have to return. I just have to return the head of this linked list. This is the head. In the end, just have to write this return head. And this whole linked list will gonna get returned. Right. Okay, so this is, we saw that if one number have only one duplicate, what if 3 have 3 more duplicates? What if 3 have 10 duplicates? So now we're gonna see that what if one number have multiple duplicates? We're gonna use the same logic, nothing have changed. So now we can see there's so many duplicates, like 2 have 1 duplicate and 3 does not have any duplicate, and this 4 have 3 duplicates, and this 5 have 1 duplicates. Okay, so how are we gonna do this? We're gonna use the same logic. We're gonna use those 2 pointers to find the duplicates, and they're gonna remove them. And so the first thing that I was doing, that I was pointing my one pointer on the head and another pointer the next of the head. So this is the next of the head, this is the head. I know this is the head. So one pointer on the head and one pointer the next of the head. This pointer will gonna check for the duplicates. Okay, so I can just name these pointers something. Let's say this is the current 1 pointer and this is the current 2 pointer. Okay, now I'm gonna check these values. So I'm gonna check the value of current 1. I'm gonna check the value of current 1 and then current 2. Okay, then I'm gonna see that do current 1 have any duplicate or not. Okay, so now I can see this thing, and the current 1 current 2 holding the same value. That means current 1 have a duplicate, which is just the next of it. So what I have to do, I just have to remove this current 2 from here, and I just have to push it just one node. Okay, so I'm gonna push my current 2 here. Okay, so what I have to do, I just have to attach this 2's next to this 3 so that this node will get removed from here automatically. So when I'm gonna write currents 1 next equals to current 2, it basically means that make the currents 1 next as current 2. So this is the current 1. Right now the next is 2. I just have to make this next as 3. Okay, so when I'm gonna do this, my 2 will gonna get removed from here automatically, and this 2 will gonna point straight to 3. Okay, got it. Now I'm gonna check again. Like for current 1, I'm gonna check again because I need to know this thing, that do current 1 have more duplicates or not. It is possible to have there will be like more 2 ahead of the 2 that was here. Now I'm gonna check again that do current 1 have more duplicates. Okay, so I can see this thing that 2 does not have more duplicates because this is 2 and this is 3, so they're not equal. If they're not equal, I'm simply gonna move ahead now. I'm gonna move both of the pointers. I'm gonna put my current 1 here and I'm gonna put my current 2 here. Now I'm gonna check that do this 3 have duplicate or not. So to check this thing, I'm gonna use the same logic. Right now I can see this thing that this 3 and 4 are not equal. That means current 1 and current 2 are not equal. If they're not equal, I'm simply gonna move both of them ahead. And now I'm gonna check do this 4 have duplicate or not. So now I can see this thing that my current 1 and current 2 became equal. That means current 1 got its duplicate. Okay, so we can see that this 4 and this 4 are equal. So when you're gonna find this thing that yeah, this got the duplicate, you just simply have to move only the current 2. You only have to move this current 2 ahead, and then you have to repeat this line again. Make the current 1 next as 4. Okay, so when I'm gonna do this, my 4 will gonna get removed from here, and this 4 will gonna point to this 4 straight away. So one duplicate got removed. Now I'm gonna check again, do this 4 have more duplicates? So now I'm gonna check current 1 and current 2 again. Yes, this current 2 is equals to current 1. That means I got one more duplicate. Okay, Now, if I got the duplicate when they are equal, that means I simply have to move this current 2 ahead, and I'm going to move my current 2 here now. I'm going to do the same thing. I'm going to make my current 1 next as current 2, and I'm simply going to point my current 1 to current 2. Now I can see my second duplicate also got removed. Now I'm going to check again, do this current 1 have more duplicates? Now I can see this current 1, current 2 are equal. That means current 1 got one more duplicate. I'm going to do the same thing as they are equal now. I'm going to remove this current pointer. I'm going to point it here. And then I'm going to do the same line. This current 1 will straight going to point to this current 2, which is 5. And I'm going to remove this 4 from here. And I'm going to point this to 5 again. Okay. Now I'm going to check again. Do this current 1 have more duplicates? Now I can see this thing that current 1 does not have more duplicates anymore, and this current 2 value is different. Now my values are different. That means I'm going to move both of them ahead. I moves both of them because like this 4 is done now. Now I have to check for this 5. So that's why I have to move my current 1 here and current 2 here so that I can check for duplicates of 5, right? So I'm going to take my current 1 and current 2. I'm going to put them here. Okay. Now I can see this thing that my current 1 and current 2 became equal, which basically implies that current 1 got its duplicate. Now simply this line will gonna help us. Now firstly I have to move this current 2 ahead. I'm gonna move this one step ahead here on null, and now I'm gonna point my current 1 straight to null. Current 2 is null. So I'm gonna remove this 5 from here. I'm going to point my 5 to straight to null. Okay. Now I can see this thing that after doing all of this, now I can see that current 2 became null. Okay. So now I cannot compare anymore. I cannot compare a null value to any node value. If I did that, it will gonna give me an error. So as soon as I get that my current 2 had became null, I got to know this thing that my linked list have ended now. That means this is my last node. Okay. So I just need to keep this in my mind that I only have to run the loop until the current 2 is not null. As soon as the current 2 gets null, just end the loop and return the head. Okay, this is what you have to do. So you need to keep two things in mind. The first thing is that if current 1 and current 2 are not equal, in this case, you just have to move both of them ahead. Move both ahead one step. And to move current 1 and current 2 one step, I simply do current 1 equals to current 1's next, right? And then I am gonna do current 2 equals to current 2's next. This will gonna move my current 1 one step ahead and current 2 one step ahead. So let's see how this actually do that. Okay, so let's see you have a linked list 2, 3, 4. So now you can see this thing, none of the nodes actually matches each other. So that means they all are different. That means there's no duplicate. So if my current 1 is here and my current 2 is here, right? And now I am saying this thing that make the current 1 as currents 1 next. So this one node is my currents 1 next. So what I'm saying is that make my currents 1's next as current 1. So now my current 1 will gonna point here. Okay. Now I'm gonna current 1 we're gonna point here, and now make my current 2 my current 2's next. So this is my current 2's next, and after that I simply have to move my current 2 ahead. Okay, so that's how these two lines works. This one and this one, they move current 1 and current 2 both one step ahead. Okay. Okay, so the second thing that I have to keep in mind, that what if they are equal? In the case when they are equal, if current 1 is equal to this current 2, that means move only current 2, then attach current one next to current two. Okay. So we saw this thing that when they were coming equal, I was making my current one move ahead, and then I was attaching my current one next to my current two. Okay. So when we were having the our two here, and my current one was here, and my current two was here, I got to know this thing that my current one and current two are equal. So I have to move this current two ahead, and to remove this node from here, I simply just gonna connect this current one next to this 3. So this will gonna lost its connection from this whole linked list, and that's what I want. So I'm simply gonna attach it here then. So to do this, we know this is the line that we have to write for the purpose of connecting my current one next to current 2. Okay. So the third thing is that I have to stop the loop, stop traversing the list when current 2 becomes null. So we saw this thing that when current 2 became null here, it basically means that my list is ended now and I have nothing to compare this value with. Okay, this current one is my last value, that means, okay? So these three things I have to keep in mind to write the code. Okay, so let's write the code. So the first thing that I have to do, I have to declare my current one and current two. So to declare my current one and current two, I'm simply gonna write node star, list node star, current one, and my current one initially will be pointing to my head. And then current two will be pointing to my heads next. Okay. After that, I have to start my while loop, which will be going until my current 2 is not null. The loop will only be running until my current 2 is not null. As soon as it becomes null, I'm simply going to come out of the loop. So in the loop, I have to start traversing from the head because my current one is here. So there are two things can happen. If my current one value becomes equals to my current 2 value, it basically means that my current 1 got its duplicate just the next of it. So as soon as I get the duplicate, I simply have to move my current 2 ahead. I'm going to move my current 2 ahead. Current 2 is next. And I'm going to attach my current 1 next is equals to current 2. After moving my current 1 ahead to the next node, I reached my next node, and after that I simply have to connect my current 1 to the current 2. We saw this thing before, okay? After that, I'm simply going to close this, and I'm going to take the else loop. If my current 1 value is equals to my current 2 value, that means my duplicate is not there. That means that current one does not have any duplicate. A duplicate will only going to be just in the front of the node and not anywhere else in the list because they are in the ascending order. Okay, so now my current one and current two are not equal, so I'm gonna write not equal here. Okay, if they're not equal, you simply have to move both of them ahead. My current one should be just ahead of it, and my current 2 should be ahead of it. Okay, so that I can check again for the current one by going into the loop again. Okay, now in the end, I simply just have to return my head. And my head is always preserved. Okay, it doesn't matter what, my head will never gonna get deleted. So let's see an example of this. So let's say you have this list, and if the head have multiple duplicates, I still don't have any problem. I have to return my head. If returning the head, you're returning the whole list after that. Okay, so firstly, my current one will going to be here, and my current two will be pointing to my current heads next. Okay, so at this particular moment, I can see that this is the head, right? This is the head, and my head have a duplicate, right? Current 1 and current 2 are equal. That means my current 1 have a duplicate. So as soon as I find a duplicate, I simply have to move my current 2 ahead, and I simply have to attach my current 1 next to my current 2. Now, as my current 1 and current 2 are still equal, I'm going to check for more duplicates. So I'm not going to move this current 1 ahead until I check for all of the duplicates. And I'm going to move my current 2 ahead. So as I moved it, and they are equal now, as they became equal now, I'm simply going to move this current 2 ahead. And I'm going to make my currents 1 next, as 3. So I'm simply going to remove this, and I'm going to connect this here. Now I'm going to compare that current 1 and current 2 are equal or not. So as I can see that they are not equal, that means current 1 does not have more duplicates. And if they does not have, like if they are not equal, then I just have to move both of them ahead to check for the duplicates of 3 now. So I'm going to move both of them ahead. My current 1 will gonna point here, and my current 2 will gonna point here. Now I cannot compare anymore because my current 2 have become null now. As soon as my current 2 becomes null, I simply just have to stop the loop because I cannot compare anymore, and this is the end of the list. That means this is my last node. So in the end, I simply have to return my head, because this head, when you're gonna return the head, this is the whole linked list it will gonna return in the answer. Okay. So this is the whole concept of removing the duplicates. So let's see on LeetCode and make this code work out. So this is our question: remove duplicates from sorted list, and you will be giving in a head. Okay, so they are giving us this head of the node. The first thing that we were doing is we were declaring our current 1 and current 2 pointer. So I can declare my current 1 as my head, and I can declare my current 2 as my heads next. After that, I simply have to take a loop which will be running until my current 2 is not null. Okay, if current 2 is null, that means it's the end of the list. So when we're going to enter the loop, I simply have to check for the values of current 1 and current 2. So current 1, if the current 1 value is equals to the current 2's value, that means current 1 have a duplicate. If current 1 have a duplicate, move the current 2 ahead one step and make the currents 1 next equals to current 2. Okay, it will gonna skip that node. It will gonna make that node lost its connection inside of the list. After that, I simply have to do my else loop. In this my else if loop, I just have to check that are the values not equal. Current 2's value. Inside of this, if they are not equal, that means my current 1 does not have any duplicates. Now I'm going to check for the next node. So I have to move both of them one step ahead, and for the current 2 also. Okay, so I just have to move both of them ahead. So this is all what I have to do for the purpose of removing the node and traversing the whole list. In the end, I just simply have to return my head. So let's see if my code works or not. So there's an error came here. Okay, I just forgot to make this current 2. This is my current 2, not just current. So now I'm gonna run it again. So we can see our code is accepted now, and it took just 0 milliseconds. So there can be like one edge case here. The edge case is that what if the list is empty? Okay, in the case when the list is totally empty, that means head is null. In the case of null list, I simply just have to return null, because if the list doesn't have anything, what are you gonna compare? And if the list only have one node, that means I just simply have to return that node only. So that thing my this logic can handle. Like if my linked list only contains one node, that means my current one will be having one value and my current two will gonna become null. My current two will gonna become null if if the list have only one node. So this loop will never gonna execute and it simply gonna return head in the end. So now we can submit our code. So we can see our all the test cases got passed, and hope you like it and hope you understood. I'll see you in the next one.